I'm Rohit of group 19 and I'll be going through our 80% of project completion. I'll be explaining what parts have been completed and what's yet to do. So our project is variable sensor HCI, which is project 4 on the provided project list, and here we want to accomplish classification of actions as either eating or non-eating based on Myodis band sensors data. The data set was provided, which comprises of one MP4 file, EMG sensor values for various timestamps, and IMU sensor values for various timestamps. So the first step which was done was return plot sensor values. What it does is it finds the sensor which gives highest variance, and based on that data, the the data is segmented into based on the maximas and minimas extracted from this. The plot is also plotted upon running, which has been so for the maximum variance. So this is the plot which was extracted, and these points of peaks and minima are considered as extreme points. Based on this, the data was segmented and the sensor values were interpolated. Each of the sensor values are interpolated and stored in a new CSV file called sensorfinal.csv, which is this entire part is done by plot sensor.python. So in basically if you open this sensorfinal.csv, you'll have all the sensor values for various time zones extracted, timestamps extracted after interpolation. This is then used in to do Gaussian filtering to extract basically additional features. This is the first step of feature extraction after classifying annotating the labels manually as either eating or non-eating based on the timestamp which is already extracted for each segment. So that is what is done in the code gauss.py. This is partially a conversion of the MATLAB file provided, and after that we've added code in order to store the file output of it as sensor underscore dog underscore final.csv. So here what you will have is basically each segment of data which was previously classified with 216 feature values instead of this thing. Basically 12 features are extracted for every sensor value, and which is stored as a single row, and each row will represent one segment. Similarly, scale space, right? Yeah, scale space is run scale space.v3 will is a code converted from MATLAB to do the same feature extraction for the same data. Same sensor segmented data to extract another additional 15 features for every sensor data for every segment, which is then stored in scale space underscore final.csv. This effectively has 270 columns, and so each of these indexes represents one segment, similar to how sensor.dog. Both of this is combined to construct a feature space of 486, so which is stored in scale space underscore. Basically both outputs are integrated and stored in this file, which has to be further used for dynamic time warping and for training of the neural net. The dynamic time warping is yet to be implemented, but we have the code which is used for written for training a neural net for the specified this thing, which takes 486 features as input, has 4 hidden layers, and provides one output. So with each hidden layer having 486, 512, 256, 128 and 64 nodes each. So this is presently being trained for random data to check its working. The integration will be done once the dynamic time warping is implemented and completed. This leaves us with just 3 paths which remain. One would be to convert the dynamic time warping to Python and integrate the file, and then based on the finally extracted data, we have to train the neural nets, the implemented neural net with that specific data, and then develop a personalized neural net and show the same output in an Android. The entire so far whatever code I've done is implemented in Python and will be hosted in a Python server, which will be communicated from the Android app through a post request. Thank you. That's it.